Hi guys, welcome to pathopulse_Radhika and discussion on genes related to neoplasia. So today we are going to see a most important gene BRCA1 and BRCA2 genes, which is important both in pathology and from the surgery point of view, right? So these are again tumor suppressor genes. So BRCA1 and 2 are going to suppress the tumor, and when this is going to be mutated, you're going to get tumors. You are at risk of developing certain malignancies. So before going into the further discussion, where are these BRCA genes located? So BRCA gene 1 is located on chromosome 17q and 2 is located on chromosome 13q. So this is about the location of BRCA1 and 2 genes. It's called breast cancer gene. BR is for breast and CA is for cancer. It's breast carcinoma gene 1 and 2 located on chromosome 17q and 13q respectively. So can you think of any other genes which is located on the same locus? NF1 is also located on chromosome 17 and RB gene is also located on chromosome 13. Okay, so other genes which are present on the same chromosome is NF1 and RB gene which is present on chromosome 13. So this is about the location. And how do these function? I told they are tumor suppressor genes. So they are going to suppress the development of tumors. So the main role of these genes is whenever you have a double-stranded DNA breaks. So whenever there is a break in the double-stranded DNA, they are going to be involved in repair of these double-stranded DNA breaks. Whenever you have mutation, this repair doesn't happen properly. So you're at risk of developing tumor when you have mutations in these genes. So apart from the other things, you have certain morphological features and risk of other epithelial tumors, malignancies when you have mutations, germline mutations in these BRCA genes. So what happens when you have mutation in BRCA1 gene? So these tumors, patients with these mutations are at risk of developing ovarian carcinomas as well. They are at 20 to 40% risk of developing ovarian carcinomas. Even when they have BRCA2 mutation, they can develop ovarian carcinomas, but the risk is comparatively less, around 10 to 20%. And BRCA2 mutations are more associated with male breast cancer. Male breast cancer. And you have certain other features. So when you have BRCA1 genes, most of the times we have to think when you have a medullary features on histology. I'll tell you what is medullary features when you see it in a biopsy. So whenever you see these features, most of the tumors which show medullary features can harbor this BRCA1 mutations, that you must remember, right? Then they are mostly triple negative. They are triple negative cancers. Whereas when you have mutations in BRCA2 genes, they are usually ER positive, your estrogen receptor positive, compared to those with BRCA1 mutation. So these are important things which you should remember. So it's not only going to increase the risk of breast cancer, patients with BRCA mutations can develop ovarian cancers, and remember two P's. They can get pancreatic as well as prostatic cancer as well. They can develop other tumors, but these are most important to remember. So they are at risk of developing ovarian cancer. Those associated with BRCA1 mutations, they tend to have medullary features, poorly differentiated, and they are triple negative. Triple negative means they are estrogen receptor negative, progesterone receptor negative, and HER2 negative. Whereas those with BRCA2 mutations, they are mostly associated with male breast cancer, and they tend to be estrogen receptor positive. So these are the points to remember about BRCA1 and BRCA2. And I was telling about the medullary features. So medullary feature is nothing but when you have a pushing border in a tumor. So look at this tumor. This tumor is having a pushing border. So this is what we call it as a pushing border. Okay, so medullary feature, one clue is pushing border, and the other one is these are lymphocytes. So all these large cells with very vesicular chromatin, they are tumor cells. All these dark blue cells with a clumped chromatin, no, all these are lymphocytes. So clue to the diagnosis of medullary features in a breast carcinoma is they have tumor infiltrating lymphocytes, they have pushing borders, and the chromatin will be a little bit like a salt and pepper. So all these are clues for medullary features. So these features most of the times they are associated with BRCA1 mutations. And another recent update is in the recent Robbins they have given something pertaining to moderate penetrance and high penetrance genes. So what do you mean by this moderate penetrance and high penetrance genes related to breast cancer? It's related to the risk of developing breast cancer. So when you have more than fourfold risk of developing breast cancer compared to the general population, we call it as high penetrance. When you have 2 to 4-fold increase in risk of developing breast cancer compared to the general population, we call it as moderate penetrance. So easy to remember, high penetrance, all the genes mostly associated with starting with P and B. They are high penetrance genes like your BRCA1 gene, BRCA2 gene, your P53 gene, your P10 gene, then the mutation associated with Pete's-Jeghers syndrome. What's the mutation? Your STK11 mutation. Then you have PALPB2 gene and CDH1 genes. All these are high penetrance. So see, most of them starts with P or B. This STK11 you can remember as gene related to Pete's-Jeghers syndrome, PALPB2 and CDH1 gene. Whereas moderate penetrance is ATM gene and check gene. You can remember like you're going to ATM and checking your balance. So ATM and check 2 gene mutations are associated with moderate penetrance. So this is about the BRCA mutations. So now let me summarize the findings or the points you should remember about BRCA1 and 2. So BRCA1 is located on chromosome 17q and 2 is located on 13q. So both are going to involve in repair of double-stranded DNA breaks. Both are tumor suppressor genes. Okay, both are tumor suppressor genes. So most of the genes which have BRCA1 mutations, they are poorly differentiated. They can have medullary features, means pushing borders with lymphocytes and salt and pepper chromatin, and they tend to be triple negative. Whereas those with BRCA2, they are also poorly differentiated, but they tend to be ER positive. So BRCA1 mutations, they are at 20 to 40% risk of developing ovarian cancers, whereas BRCA2 is 10 to 20% risk of developing ovarian cancer, and patients with BRCA mutations can develop pancreatic as well as prostatic cancers also. So these are the important points which you should remember when you're thinking about BRCA mutations. And if there is a strong family history of breast cancer, we do screening for BRCA mutations to identify it and prevent it at an early stage or treat it at an early stage. And we discussed about the penetrance genes, high penetrance and moderate penetrance, which is included under the recent edition of Robbins. So high penetrance are at high risk of developing cancer when they are mutated. So those starting with B and P, your BRCA, P53, P10, STK11 gene associated with Pete's-Jeghers syndrome, PALP2 and CDH1 are at high penetrance genes, and ATM and CHEK2 are moderate penetrance genes. So thank you so much for your patient listening. We'll meet you with another gene soon.